Welcome, friends, for this Ferro Talk show number 18, arranged by Ferrocement Society of India, Pune. Our today's guest speaker is engineer Padmanabh Lele. He's a constructor and designer in Pune, and he's also vice president of our Ferrocement Society currently. He has built several structures using ferrocement, and he is working in this field since almost 25 years. He started Ferrocement construction with a small tank of 5,000 liters, a square tank, and then thereafter he went on very implementing innovative ideas in Ferrocement, including designing of those structures. We have seen his big structures, a unique Ferrocement bungalow, totally round in shape, on 1 acre land in Pune city itself, and it is a marvel, we can say, uh, where we can see all the ferro cement elements have been casted in a unique way and also designed very nicely, right from foundation to the roofs. For that bungalow, he has been awarded with late V.D. Joshi Prize, and currently he is experimenting on precast panels also. So while constructing ferro cement components, a lot of care is required to maintain the quality, the shapes, the desired shapes and surfaces finishes. So on this issue particularly, Lele sir has come with his presentation talk about the shortcomings during ferrocement construction. So this way, today's topic is unique. We will be highlighting the shortcomings during the construction and how we should overcome them while applying this ferrocement technology. So let us see his presentation. Over to Lele sir.
Today, I'll speaking on the practical problems that I have faced, and also seen others also facing the same problem. So, while working in the field, I found that I am getting drifted from the theory part of it. So, practically, what happens? Our laborers force us, sir, we'll do this, this will save our time, that will save our money, it will fast. So, our client pressurizes us to make it fast, completely finish it as early as possible. So we get drifted. I get drifted to some extent from the logic behind the construction. So I faced some problems while getting the work done. What happens if when we get drifted from the theory, quality is affected, and we didn't get the result as expected. So I will put forward some of the problems which I faced while executing the work, and I try to overcome those problems by some thought, and other experts can suggest something more how we can improve the quality of the work. First of all, what happened? The first problem I faced during I did a water tank of 5,000 liters in 1995. It was a rectangular water tank. What happened? I had never experienced how to get that ferrocement work done. I saw the work done, that tank package, and they plaster it. I thought there it is only a plaster thing and not press filling. So I get it done, fabricated the whole structure because I had one welder, very good welder. So we fabricated the rectangular tank, tied the meshes, chicken mesh, weld mesh, whatever we saw people doing. So we tied chicken mesh, weld mesh, everything, and asked the mason to plaster it. So he started plastering, and we faced the problem. The thickness, it was not press filling. Please take it consideration. It was not press filling. We were just plastering it. So single course was plastered initially. Somehow we pressed the mortar, make the balls of the mortar and pressed it, then plaster outside, plaster inside, and ultimately overall thickness was about 3 to 3.5 inches. And ideally we expect that to be 1 inch or 1.5 inch or maximum 1.5 inch or 2 inches at the most. But actually it was more than 3 inches, 3.5 inches. At some places it was 4 inches also. many times we do the same mistakes. Before pressing the mortar, we have to ensure the plumb of the sealant should be there. We have to check the plumb. What happens we do if we didn't check the plumb? We press, even though we press fill to make it in plumb, we have to add some mortar, extra mortar, and if it is out by half inch only, so then from both sides half inch, your thickness will increase by 1 inch, and also you will add some plaster thickness, and ultimately what will happen? Additional thickness of plaster, it will cause the cracking of the surface. So our theory will go away, and the cracks will be there, and we will face the leakage problem through it. There are chances of that. Due to the crack may not go inside to throughout, but there are the chances. Chances of leakage are increased, and also we waste most of the mortar just for due to negligence or plumb that will happen. Another thing we have to ensure that we have to support that vertical surface properly so that it will not go out of plumb during the press filling work. In this side, you can see that we have used this actually as a shuttering because that beam was there and we tied the meshes from both the sides and pressed it on one side. You can see inside of that beam because this is pressed it from one side only, and another side you can see that rough surface and partly you can see the meshes also.
Mhm.
So what happens if this is the way? I don't know what will happen theoretically. Most of the time people use this technique but they just press it from one side. But how can we ensure that all the mortar is exactly covering all the meshes and exact all the it is properly press filled? We cannot ensure like that. When we apply plaster from another side or press fill the mortar from another side, the age of both the plasters will be different and there should be proper bonding between two surfaces. If it is homogeneous, definitely the strength will be more. And if it is not it will not be homogeneous. If we press fill from both sides at different days, today and day after today, then it will hamper the strength of that total homogeneous mix. So that is the everyday problem. I have seen at many places people work like that. So
So, you mean
theoretically,
how to do the spilling from inside?
we have to do both the sides simultaneously, parallelly.
But after this placing of reinforcement, can we do
Uh,
the press filling from inside?
no, in such cases, no, in such cases it is very different. In such cases, it is not expected
Ah,
because this ferrocement is only as a shuttering we are using.
right.
Structurally, we are not using it.
Mhm.
So in such cases we can do, but when there is structural use, definitely strength matters,
Right.
and it will be less strength that we expected, whatever we expect. Similar is the case for the slab work. Here in this particular slab, this slab I have done in Y, but here in this particular case, I have used shuttering for the slab, and you can see in next slide the final result of that slab. It is form finished. You can see here and form finish. And these ribs, I have done precasting of these ribs. And you can see the ribs are joined and I have put some insert right and with the help of the insert, I have welded those ribs to each other and the side beam. So it has helped a lot. And this slab particularly was totally watertight. This was a total about 6,000 square foot of slab. And this was totally watertight. No waterproofing treatment was provided on the top, but still for 3 years there was absolutely no leakage. But before using the underfloor, they didn't took the chance and they did some polymer waterproofing on the top of it because that hospital was there. So for hospital they didn't wanted to take any chance. So they provided chemical membrane waterproofing on the top of the slab. But while casting, I experienced that I've seen. I use needle vibrator while casting this slab, and that needle also when I put the stiff mortar 1:2 proportion on the top of it, and it was very stiff mortar. When I used the needle vibrator, it took the same time as 4-inch slab requires in a case of RCC.
Mhm.
But that result was fantastic, and form finish and everything was there. Leak proof, form finish, whatever we learn in the theory of the ferrocement, everything was there.
So needle in horizontal,
Another short,
that
yes, please.
needle, vibrator needle was put in horizontal position or vertical position?
Yeah, vertical position. Horizontal, it is impossible. It is 30 thick, and thickness is exactly 30 you can measure at any place
Mhm.
that I have insured.
So then
It
why
is 30 thick slab.
so why not plate vibrator was used then?
It was difficult because I had that needle vibrator to bring that plate vibrator. It was difficult. I didn't have that plate vibrator, and needle vibrator serve the same purpose,
Mhm.
so no problem for that. This is for the slab, and same is the case in at the time of domes or shell structure. When we go to the top, that surface is again nearly horizontal. So same thing happens in case of domes also. I have observed in the dome work. I did a dome near the Dapoli. That was 40 feet dome, and I made some mistake while fabricating the rib beam of the same. In this slide number 7, you can see there is a rib beam that was erected, and you can see visualize it is vertical. Actually, while fabricating, I marked a circle on the floor. I made the fabrication. I have erected in the part, but it was not bent to the as the shape was there, dome shape. And in next slide, you can see that dome shape is not exactly round. So to make it in hardly that difference was hardly 1 inch or 1.5 inch. But to make it that bring it to the shape, I had to put extra mortar, I had to put extra meshes from outside. And initially about say 25% portion or 30% portion I did with this vertical exactly right angle position stirrups. But when I noticed that it is going out of shape, finishing after finishing the dome, it was exactly round shape. But at the doors in the openings, anybody can see that thickness at the end for this portion is has gone to 11 inches or 12 inches, and where I did the correction, it was exactly 9 inches as expected, as designed. But for some portion in the doors, anybody when visits, civil engineer can visualize that here the thickness of the jam is more, and on the other end it is less. These are the mistakes commonly I did, and I think other exhibition work might be like these same, because nobody is going to check the thickness after finishing. That because it matters only that finish how is the finishing. But practically we waste more material, we waste more labor and natural resources, and maybe due to extra thickness of plaster, cracks will be there, and we face the more problem due to cracking and leakage problem may be there. So we have to take care while doing such type of work. Another problem, people oppose use of crushed sand. I am working with the crushed sand for last 22 years, but in last 5, 6 years or 7 years, I have found that crushed sand that we are receiving is having much more percentage of the dust. Actually, stone dust is a wastage. So they put that wastage in the crushed sand. They mix that wastage of dust in the crushed sand, And what happens that all the mix design is gone off, and we have to use extra cement, or we get what, what we don't expect. The strength of the mortar is reduced, so we have to take care while using a crush sand or any other sand that in river sand, make sure that steel content is less than 5% as per our code of practice. And for crush sand also there are provisions that percentage of dust should be minimum, and we have to observe that fineness modulus of crush sand while using. So after looking at this, I decided to that why not do the precasting of the elements. And I don't have factory, so I did it on the site. I tried with precast beam and slabs. You can see in the photograph, the slide number 9. I made the panel of 1-inch thickness with tongue and groove joint. You can see the panel of slabs. I made precast beams also. I erected those beams in position and laid the slab panels with the jointing, and I put the cement on the joints. And ultimately what happened, in first rail it was okay, it didn't leak. In second rail it started slight leaking. So the persons using below, they complained me that now it has started leaking. So to overcome that, I have fixed one layer of chicken mesh on the top of the slab and plastered it. But what happened ultimately, it lasted better than previous only cement filling up with the joints. But after 3-4 rains, it again started leaking slightly. So I thought what might be wrong, but then I realized what mistake I made. That all the joints are only chemically jointed. So the elements are joined chemically, that means with the cement. And there are movements when we use just like steel structure. When we use steel structure, there are always movement in the structure, and with those forces of the movement, these joints will not cannot withstand. Only cement cannot withstand the structural movement for those various elements. So in that previous, you have seen the previous casted that 30 mm thick slab. On while doing that work, I only precasted the ribs and I kept bars open, and I welded the slab bars with those rib bars, and then that slab didn't leak at all. And for keeping the position and achieving the exact strength, I used shuttering. I was able to remove the shuttering next day or day after one day, after 36 or 48 hours easily. There was no problem at all. It took very good load condition. It standard very good for the load conditions. So mechanical jointing should be there. That's what I think. And only chemical jointing with the cement will not hold it properly, and we may face the leakage problem. So welding or nut bolting should be there. That's what while precasting the various elements we make in the factory or on site. So that care should be taken while precasting and joining the elements on the site. That care should be taken. And what other point happened that this while joining the our thickness of our precast elements is very less, 25 mm, 30 mm, like that. So while handling, I found that corners especially get broken. So we have to take care of that also. While transporting also, that possibility is always there. So that joining, that cracked portion may leak later on. But if we join with proper use of meshes tied with the original meshes in that precast portion, then the chances of leakage are totally reduced. Let's say zero, because I have tried for the precast tanks also. I have done water tanks with precast elements, and I kept ends open and welded those ends, and that much portion I did side casting, and it has performed very well. No leakage was there, and we can use this technique on the site. But some more research or practice is required to train the workers and supervisor staff how to cast it, precast it on the site, and how to join it. I have done some experimentation with that also, so I can share anytime if anybody is interested. Some questions, I have some questions now for the experts who can guide me. That ferrous thickness of the ferrocement and plaster thickness. What is the dividing line we can decide? We have to decide what is the dividing line. When ferrocement is stopped and when plaster has started. Because overall thickness matters. What happens, any client, we claim that our thickness is 1.5 inches or 40 mm, but at the end, when he sees that thickness is 3 inches or 3.5 inches or 2 inches, up to 2 inches he can tolerate. But when it goes to 3 inches or 3.5 inches, anybody will think, why not use RCC if your thickness is going to 4 inches? Then why not use RCC? What is the difference between your ferrocement and RCC? You are getting 4-inch thickness, and for RCC, if we didn't plaster, then there will be it is not possible that we can cast a 3-inch paddi or 4-inch paddi. Then why should we go for ferrocement? So we have to define ferrocement thickness and plaster thickness, and there should be some exact dividing line. I cannot make it that this is plaster and this is ferrocement. Another, slab shuttering removing. I have removed it within 36 or 24 hours or 48 hours for ferrocement. Is it right or wrong? I don't know. Theoretically, maybe Milind sir can shed light on it. That shuttering removing as per IS, but IS for the ferrocement, we are working on it. So that some guidelines should be there that you have to keep the shuttering for this much period, or some guidelines should be there. Another question in my mind is, if we, as we have seen earlier, if we put the mortar from one side, then what happens to the bond between the two layers, its interaction between each other? While doing double coat plaster with for sandless plaster, I have done sandless plaster in 2 coats. What we do, we apply first coat and make it rough, and finishing coat we apply later. In that case, if the time is delayed or there is much dust on the surface, uh, first coat, then there are chances the second coat peels off. Many times I've seen, I observed at many sites, the second coat it peels off, and you can see the rough coat inside. So the bond between two layers is equally important. That's why I insist that we have, while casting the walls especially, we have to press fill the mortar both the sides simultaneously. That will give better result. And also for plaster, it will be better to use bonding agent for the same. And another question, while joining with the structural steel, proportion between volume of steel content of that structural steel member and volume of mortar of ferrocement that we are using. Expansion contraction of structural steel is different as compared to our mortar, ferrocement mortar. So that relation, theoretically, what should be the relation, I don't know. So experts and academicians can tell me about this. What should be the volume of steel content and what volume of mortar? So that is my question. What should be there? And can we fix directly apply plaster to say channel section or eye section? Will it withstand in the long run? That I don't know. Actually, this topic is for not for presentation. This topic is for discussion actually with the site people and also theoretician, academician, and consultant.
Thank you, Lele sir, by giving such an insight about the shortcomings during the construction of ferrocement components. Thank you for presentation and posing various problems before the experts to answer. First of all, I would like to have the comments by Shri Mohammad Sadiq ji about his experiences regarding these problems.
Actually, we don't go for precast beam and slab separately. We go for precast slab as well as some rib, uh, as precast rib combinedly, and then we put it there on the beam, and the actually the depth of the rib depends on the span of the you see span. Yeah, it depends on the span. So that is a little bit easy to you see place in the field. But I think it is we can try this way also. It may be. But one thing actually, I am a little bit I'm not sure regarding the use of shutter for beam. So if we place the main bar of beam and we just put some mortar as shutter, maybe up to 25 millimeter. Then my question is, usually for reinforced concrete structure, the stress transfer usually stress transfer occur through concrete, so, through bonding, and if the main reinforcing bar of beam, if we just cover part or full of it by mortar, then the stress transformation of beam as main reinforcement, how actually it will occur. I am little bit actually confused. It's not the mechanics is not very clear to me. But what I believe, if we use the ferrocement lining as shutter material, then we have to put again at least 25 millimeter clear cover from the main reinforcement of the beam. Then I think it's fine. Then it's no problem. But if you use no clear cover from the ferrocement panel, then I don't know the how the stress will play during the load transfer. That's my question also actually.
Okay, okay. Thank you, Radik ji. He has posed many questions before us. I have noted it down and we will go one by one to discuss and get the answers. He started with the first question that he showed one slide regarding the casting of component in the lost formal type, where the enforcement for the main component is already in place, and we have to cast only the ferrocement component in the as a formwork. So for that, only one side clustering is possible on the field. So what to do about the other side? The steel gets exposed, is not completely covered by the mortar.
But one thing, if we consider this ferrocement lining only as the substitute of steel shutter, then I think, and if we can provide some extra clear cover from the main bar to the ferrocement lining, then I think it's, even if it is not well compacted inside, then it's no problem. But if I use as a structural member, the ferrocement lining as structural member and integral part of the beam, then it's a problem. If yeah, so
Yeah.
actually the design, what is our design philosophy, that is important. What I believe.
Yes, so this is the one type he has shown regarding the lock polymer type. The another thing he also explained that say it's as a structural member, it's a casting of a water tank, for example. So where the both sides are open and we can press fill it nicely by covering it from both the sides. But even in that case, there is a lack of proper plastering or finishing from the inside. And another problem simultaneously he has also posed that the plastering or the mortaring in layers, which should not happen. If we do the excessive plastering just to finish it up, then it may hamper the strength itself. So I think I will go to Divekar sir to explain better what will be the theoretical requirement and how it affects this kind of casting and design construction.
First question that he raised was, what is the demarcation between the plaster and the thickness of ferrocement?
Right.
That means what should be the cover? Indirectly, he wanted to ask that what should be the plaster cover on the wall that we cast. Actually, by definition itself, we say that the meshes are impregnated with mortar with a cover of 3 to 5 millimeters only. The wires are very close to the surface. Now, if you want to later on apply plaster on it for finishing, say sandfest plaster or smooth finish, that plaster is not at all going to account, is not going to work as a ferrocement element. That is just a finish.
Right.
So the cover actually, as per definition, is only 5 millimeters or 3 millimeters, and that can be achieved like this: that we are having the skeleton steel first, bar skeleton is made, on that weld base is tied, and on that we tie chicken meshes very tightly.
Hmm.
Those chicken meshes are so tightly tied that they hold the mortar. In RCC, we are embedding the bars in concrete. Here, the wire meshes hold the mortar. And when they hold the mortar, hardly the finish comes out on the wire meshes, the cover may be hardly 3 to 5 mm. It can be achieved. And in case, suppose we are having 8 mm diameter framework and we use weld mesh on two sides and say chicken meshes for four layers on two layers on one side and two layers on other side, the mesh thickness itself, the cage that form, works out to be about 22 millimeters total thickness. And that thickness, when added from two sides of 5 mm cover, it works out to about 30 mm.
Right.
So automatically the thickness is built. And actually, when Dr. Pama had been one of our chief guests here, and we have met our one of our friends has asked that how can we find out the specific surface on that when the plaster is there and thickness is so 4 inches and 3 inches, how it can be worked?
Hmm.
At that time, Kama had also pointed out that the thickness is built by the base, whatever is the mesh thickness total, and cover only on 3 to 5 meters on. That is the ferrocement.
Right. So
And for designing, you can take that.
yeah. So you
That
mean
is
to
a
say plastering is not at all expected. It is just to get
plastering. What happens while we filling in, we cannot have that smooth finish.
right.
We go on pressing material on plate shovels, and that we cannot get that smooth finish.
Hmm.
That is why, and in water tanks and all that, inner surface is required to be smooth, outer surface is required to be sand phase because it is exposed to atmosphere. It
Hmm.
is not only the water tightness that is to be achieved. We have to see that when it is exposed, all the outer sides of the water tank are exposed to atmosphere or sun rays. So that crack control will be achieved only by sand facing. So
Right.
that plaster part is different.
Right. But here also,
Just
it,
I want to add, Sir Divekar sir.
yes, yes,
So this is one issue. Yeah, it's okay. You are very right. Another issue is if somebody say, okay, during plastering, I will put additional wire mesh. Then I think another problem still is there. Usually, for ferrocement, we use the proportion 1:2, something like that. But for plaster, I don't know in India. In Bangladesh, usually we put 1:4 for plaster. So if the ratio is 1:4, even if we put some additional, you say chicken mash, then also there will be a problem. What is your opinion?
Sir, in this case, even in old constructions, whenever we are doing brickwork or there is a joint between the RCC and brickwork or between column and slab, wherever there are openings or cracks are there, we use chicken mesh is tied over it and it is plastered. That is not ferrocement. In that case, the wire meshes act as crack arresters. They act with the mortar, they are bonded together strongly, and that is why they won't allow the cracks to be extended further. They act, it is not at all ferrocement. We are not doing ferrocement in that. When we cover brickwork with chicken meshes or say joint between the RCC and brickwork, that is only covered with chicken mesh and that portion is plastered. So that plaster's quality is improved.
Right.
It acts as a resisting the cracks which will be formed, those that will be acting as arresters.
Yes. Now I
One
will
more
just
question, one more question Lele sir has asked about the formwork that he has used. That means for the
before that, I will talk about just two lines about the plastering point. Then we will go to the formal side. Just to extend his question, he has also posed that okay, now it is clear that the plastering is not a part of structural member; it is just for finishing. But if there is a time lag between the original ferrocement casting and the plaster, then it becomes layered and the bonding problems crop up. So, what is the solution to that?
no, in that case, suppose we are doing the water tank or say walling today, we draw lines on it, we make it rough.
Hmm.
Even if it is delayed, plastering is delayed, that as we do for any other thing, the roughening of the surface is already made. When the mortar is very green, in that case, we draw lines on it, we keep it rough, and then the plastering is made.
Right.
Even if
It
it is
is
made
not
after 3 to 4 days, no problem is there. That adherence is there between old work and new work.
okay. So this is not layered casting, right? It's only single layer.
Yeah, uh, that plaster is for finishing only.
Yeah. Okay. Thank you. Now to the formal question.
Yes. About formwork,
Yeah.
as Lele said, had already pointed out the beam that he has cast, that in that case, the steel requirement of the beam, whatever was there, bottom layer, whatever bars were put in the sides as webs, as say shear reinforcement, all of them are already put. And he has used wire meshes only as a sort of say cover, only cover. It is not acting as a structural member. The structural member is the steel that we put in, and later on, now he has pressed mortar from outer face. That in those meshes, chicken meshes, there will be protrudings inside. There will be projections inside because there is no support given from inside.
Right.
Only from one face the plastering is made. So those protrudings later on when we put in concrete in the beam, when because it is a RCC beam, when if we put in concrete in that, those protrudings will be providing a sort of anchorage for the concrete to make it one.
Okay.
That is
So
how.
you mean to say even if there is some extrudence of the chicken meshes, that doesn't
Yeah,
harm.
yeah, there will be. When we press mortar, inside the mortar comes out from the chicken mesh from the other side.
Right.
And those protrudings will be helping to hold to have bond between the new concrete and the cement mortar that is pressed.
Perfectly. Thank you, sir. Now we'll go to the materials quality problem. He has posed about the problem of crushed sand coming with the stone dust and so many things, and also about maintaining the shape of the. He has given the example of dome or even as a vertical surface with a good finish. So for that, the plums and other line and length is to be maintained. So about this material qualities regarding crushed sand and other materials also, and about how to maintain shape, I will go to the Milindji to give us the uh, solution to these problems.
So one thing is very clear that everybody should be on the same platform as far as what is ferrocement. It is thin walled. The moment it becomes thick walled, the specific surface reduces, the strength reduces, and it comes very closer to RCC. The more thicker you are making, whatever means it will come to RCC, because you're talking of bonding the plaster also to the core press and fill. So you are making it more and more, more and more bonded. So it behaves like a one section, and larger the thickness and lesser the reinforcement, its specific surface will reduce and it will start behaving like RC. So the fundamental challenge is to make it thin walled. Now press and fill has its own inherent problems. What I have done is I have put a 25 by 25 mesh of very small diameter weld mesh on the outside face of a rectangular tank. This is a rectangular or square or say circular tank. We have put a mesh and we have put sacrificial plaster, what is known as dash coat. We call dash coat, 673 mm. You just do a dash coat and allow it to cure, and that dash coat acts as formwork. And then from inside, you have got all the power and strength to press and fill the entire mortar the way you want to. If you want to do press and fill, and after doing press and fill, the leveling is not done by plastering, but it is done by acrylic cementitious putties and what is known as patra finish. Lele sir will know better. You have a patra finish, and every layer of patra finish is 2 mm and 3 mm. So 2 layers of patra finish is very good enough instead of plastering. So that patra finish will add only 2 to 3 millimeters in one round, another 2 to 3 millimeters. So the academic theory of ferrocement of 5 mm cover still holds valid. You can have 2 layers of patra finish putty and line and level it properly. If the press and fill is not done properly, you might have to do more, but do not do plastering from inside. Similarly, you do the acrylic putty finish from outside also, because you have done a dash coat. Thereby, you will ensure that you have achieved your thin section, if not theoretically say 20 millimeters up to 25 millimeters, if worst to worst. So that is the standard deviation that we should allow ourselves. When I'm designing for 20, it should not be 35 and 40. We have lost the game there. We have lost the game of ferrocement. So that is one thing that is there. Second thing is, as regards, um, I believe that there is no provision for plastering in ferrocement. Plaster and ferrocement don't go hand in hand. Plaster, you can achieve the cover which we are fighting for and advocating for of 3 and 5 millimeters. It can be achieved by an acrylic putty, which can be easily be doing by patra finish. So that is achieved. Now same thing happens when you do strength through form and shape. Suppose you have a dome, suppose you have a barrel vault, suppose you have a funicular dome. One layer of plaster or dash coat, I would not use the word plaster, dash coat on the top side with a 25 mm gauge weld mesh, so that the dash coat remains, it is cured, and after curing from inside you press and fill and then do it with a putty. Now this is the answer to basically doing the work by press and fill. Now if you're doing 2 or 3 layers of acrylic putty, then you might have to apply a chemical bond coat, which is very easily available. Acrylic bonding agents are available. You just plaster, put the bonding agent, long pot life and bonding agents are available. You do that and do another acrylic putty. Now this is the only way I can look at press and fill method. So press and fill is a very big challenge for all of us. And I believe that one layer of dash coat on a 25 mm square size of the weld mesh on the outside and curing the dash coat and then press and fill from inside, that is some form of formwork is required, which will eventually be again closed later by the acrylic putty from outside.
Yes, yes. Just one more added question to you only about the removing of shuttering within 24 to 36 hours.
Now
Is it?
this is the most important thing here is the strength of M30 grade mortar. For that, you can just do accelerated curing tests with the cement and the sand that you are using at site after all the sieve gradation, and do it in any laboratory available. Accelerated curing is available. You can take 3 day, 7 day, 14 day, and 28 day strength of the mortar, and accordingly plan your deshuttering.
Yes.
But you will require half the strength at least before you deshutter the. Uh, we don't even do that. We take 3/4 of the, say, when the strength of the mortar is M20 and you have designed it for M30, you can start deshuttering. But that is the technical answer. Generally, we don't risk that because uniformly M30 grade is not available at site.
Right.
So you have to keep for 14 days at least, knowing well that in the lab you have done accelerated steam curing and you have got the results, very good results of your mortar that you are going to cast. Thirdly, most important point is now that the mortar itself is undergoing a technological change. I am not looking at mortars at all now for press and fill. I would make two weld meshes of say 100 by 12, keep a gap of 15 millimeters between them, put 6 mm stiffeners inside face vertical and chicken mesh tight, and in between pour micro concrete. That micro concrete is self compacting. It is now also self curing are available, most important. So self compacting micro concrete that is poured comes out from both the sides and that can be finished. Now this is the necessity and this is the innovation that has come in the recent times. So present fill might go out and micro concrete filling might come on in as a new method probably, because it is much easier to do and it doesn't require skilled manpower. This is most important. And
What is
uh,
micro concrete?
micro concrete is nothing but see the particle size for cement is about 100 microns, particle size of cement. So when you grind the cement further, the particle sizes go on reducing, and you have different grades of micro concrete. For our work, generally 16 micron grade particle size cement is grinding is done, and it is available commercially in the market. It is also available as an additive to cements and mortar. You can just put an additive, and it becomes free flowing. That mortar which itself becomes free flowing, and pour it. That is the only way to do cast in situ. Otherwise, precast is still the favored choice. Even precast at site, even precast at site, you just make a form and pour the micro concrete with the reinforcement that you want, and you want whatever thickness you want in design, you will get that thickness. You will want 12.5 millimeters, you will get 12.5 millimeters. You are pouring micro concrete.
So the same cement can be used for our Ferrocement mortar also instead of
Yeah,
concrete.
that comes with the finely graded sieved sand also, which is suitable for us, and you can just add a specific amount of water and just
With the same
pour it.
grade, strength of the
Yeah,
cement.
you get M30, you get M40, you get M60, you get M80. You can go up to M80 also. So that is the answer now. So press and fill is become a problem because of skilled manpower. And to avoid that, one sacrificial dash coat on the outside is must. Let it be cured properly, and then from inside press and fill completely. And don't use plaster for finishing. Use acrylic putty, cementitious. They are waterproof also. The putty can be very finely lined with the patra finish, what they call patra finish, and you can get what you want even in cast in situ. Second option in cast in situ is micro concrete. And in precast itself, at site, micro concrete works wonders. I have done it at Karjat on a site where we have made the forms, and we have used actually square tubes which are used for wiring, because they were 25 millimeter tubes. So we have put on the wooden ply, plastic wooden ply, those 20 tubes, and we have put the weld mesh, no chicken mesh, 2 layers of weld mesh, and put the micro concrete. And then for 3 days I have cured it, and after 3 days, instead of making a curing tank or everything, we have sprayed silicate based curing compounds, which are the best thing in the current situation, because you are on the flood committee. There is flooding and there is no water for construction, and the collector issues a fatwa in April that no construction will be allowed. So for curing, the whatever water is required also can be used through these silicates. So this is going to be a game changer slowly if you want to really promote ferrocement.
Yes,
That's
yes.
what I
Thank
feel.
you, Milind. You have given a very innovative and the latest technological solutions to these small problems. But
No, there is no answer, sir. Otherwise, the first we are actually crossing our swords as constructors with the first word of the definition thin walled.
right, right.
There
Perfect.
only we are falling down on the ladder. Actually.
Yes, yes. Thank you. Now, this question is to Hangekar, sir. About the crushed sand, since he knows all the government quarries have been banned and only natural sand is not available, and day by day we have to switch to 100% to the crushed sand. So the problem he has posed about the crushed sand is the inclusion of stone dust and maintaining the quality. Even the advanced granulators are also available these days, which will give the perfect round shape and with the proper fineness modulus, which is required for the next designs. So, what is the solution for these crust sand problems while we are using the Ferrocement construction?
Yes, yes. Presently, in all this private construction and government construction also, river sand is a problem. And moreover, this manufactured sand, or what we call as crushed sand, that also is giving more problem because of mixing of stone dust in it. So many a times it gives false impression about the green color of the cement mortar or cement concrete, because this dust, they use less cement, and we get the impression that this is a very green color concrete or mortar. We must be aware while using the crushed sand, because the stone dust component or percentage is much more. So sieving is the only thing we can do, and secondly is the washing and sieving. Both the precautions can be taken so that we can use safely this crushed sand in construction purpose. Many government organizations, they are pushing that use crushed sand instead of river sand, because there is a shortage in river sand. So I think proper precautions are to be taken while using the crushed sand.
We will take care about the quality of the sand by screening and these other methods what Hangekar sir has suggested. Now there is a last question to Divekar sir again. The problem about the composite structural casting with structural steel. So is there any specified volume ratio of the structural steel and the ferrocement mortar? So what one is the feasible, or how we design theoretically in the proper way, so that the proper bonding can be there.
Actually, the thermal coefficient of expansion of steel and mortar, they are quite different.
Right.
In when we uh, go to ferrocement, we are adding meshes to it, so that expansion contraction of cement mortar only, when it is converted to ferrocement, is definitely improved. But generally, what I have observed, I haven't got any formula or anything like that. I have not worked on it. But when we saw that we use 10 diameter bars, and the thickness of the product is say about 25 wall is 25 to 30 then in that case, along that 10 bar, there is a crack. And generally, it is specified also that 50% of the cross section area of the wall or say the member should not be exceeded by steel bar,
Okay.
whatever skeletal steel you use.
So
About chicken
50%
mesh
can be
and weld mesh, there is no specification, but the skeletal steel that we use, because that is much in quantity at a place. Otherwise, the meshes, chicken mesh and weld mesh are spread throughout the section, but the skeleton bars are at certain distance, and at that place only it is possible to have cracks. But I have not derived any formula. I don't know any formula. What should the percentage of the cross section so that this cracking can be controlled? I haven't got any data about it.
This
right.
the solution for this. The solution for this is the skeletal steel should not be considered to be spaced at 300, 400, 500 millimeter center to center. The skeletal steel to stand on its own, if it's able to stand with that spacing, well and good. If not, then you have to always as a what do you call, one of the commandments of ferrocement is smaller diameter bars at closer spacing. You use 6 at 100 millimeters, doesn't matter if your cage is very big and it is not holding on its own. But never ever come to 8 or 10 or 12 because as sir said rightly, there is 100% cracking
Right.
at the location of the bar.
So I just, Milind sir, I want to know one thing.
Yes.
If we use the ferrocement lining for as shutter, then there will actually initially when the ferrocement part become hardened, no vertical load is there, and when we will go for casting for beam, and this ferrocement lining and beam will be integral part. Then after taking out the prop from the beam, then there will be some deflection, especially in the middle part of the beam. Then the ferrocement part will crack. There is a possibility of cracking this outer ferrocement part.
You're referring to a hybrid RCC beam and a ferrocement slab.
No, the one actually Lele-san showed that.
Yeah, no, that is very challenging. That is very challenging. But the point remains that he has used precast beams. There already curing and strength is already achieved. So he has not taken the risk of the propping those areas where the beams are already precast and cured, and then he has connected to the slab later on. He has done a good thing by ensuring that. But what you are saying is also correct. If you are going to do cast in situ both the slab and the beam as a cast in situ thing, then centering is to be maintained properly, because again quality control we don't know. We do not know M30 grade. I am also not very comfortable at all casting a ferrocement beam with mortar. You can maximum use a fast flash some plasticizers are available. Flash some. You just pour that mortar into the beam cage. That's what all you can do. Otherwise, pour micro concrete. If you don't have micro concrete, you have a flash slump hyperplasticizer is available. You just add to that mortar and it will give you a slump enough to pour into the beam cage, and then immediately it will set. So that is another answer. Now this is all technology that is coming in to help us to come out of Lele sir's difficult questions that need to be answered.
Yes, certainly there are solutions. Thank you all the experts for giving the perfect solutions to so many problems which Lele sir has put us to the task. In fact, instead of hearing from him his experts construction methods and various problems, while presenting he himself put up the questions before us. We have got many good solutions like use of dash code technique for maintaining the shapes, and then the patwa finish for plaster, keeping the minimum cover maximum up to 5 meters, as Divekar rightly pointed out, since it is not the layered structure, and use of the super plasticizers, the latest technologies, the self-compacting micro-concrete technology, the curing compound uses of that. So many innovative solutions are there for the problems we are facing right now. And certainly it is required for maintaining the good quality of the ferrocement. Unless we maintain it, we cannot get the desired strength. And only because of the lack of workmanship, the proper training, and with the proper these solutions, if something goes wrong or the structure fails, the technology should not be blamed. That care everybody should take. So with this note, I thank finally today's speaker Lele sir and all the participants who have given a very excellent solution for the problems. Let us keep going and see you next show for 9 on next Saturday. Thank you very much and good night to all.